Okay, let's pick up from where we left from last week. We spent one entire lecture in section 5.1. Basically, we focused on NPV method and how we can apply the NPV approach to decide whether a project should be accepted or not. Today, we start the next section, 5.2, nominal versus real interest rates. This is a rather simple section, and we can finish probably in 10 minutes. Before we start anything, I want to give you a rather simple example to somehow, demonstrate the meanings behind nominal and the real interest rates and why the real interest rate really matters to us. So assume now we are at time 0. Okay, so we are here. So 0 means today. Assume that I have $1 today. And let's say now a dozen of X costs exactly $1 at time 0. Okay, so this is time 0. That means I can use my $1 to purchase a dozen of X at the current time. Okay. Now assume that I have another option. I can deposit this dollar into a saving account. Let's say for 1 month. So here's 1 month. Let's hypothetically assume the interest rate for 1 month is 2%. So if I don't spend my dollar today, I can put it in the saving account. I will leave it in this account for 1 month. Assume it's 2%. So in the end of 1 month, I will have $1 plus extra 2 cents. Okay. Assume now at time 1 month from now, a dozen of X costs, let's say $1.20. Well, on paper, my wealth just increased from 1 to 1.02, meaning the rate of increase is 2%, which means I actually earned 2% on my entire wealth over the last month. Okay, but in real purchasing power, my purchasing power actually went down, right? So there's no gain in this. This is a very simplified example. In this example, X is the only goods, for consumption. So I use the price of X to measure my actual purchasing power, right? So at time 0, my purchasing power is actually 12X. But at time 1 month later, well, it's definitely not 12, right? I will have to do the division, right? It's a little over 10, right? So my purchasing power just went down from 12X to about 10X. So there is no increase in my purchasing power, right? So purchasing power is something we really care about because that is the real increase in my wealth, right? 2% is only the nominal increase. Right. So on nominal, my wealth went up by 2%, but how much I can purchase does not increase by 2%. Right. In this particular example, it actually went down, right, by actually more than 2%. So we about 2%, right? So it's 2 divided by 12. So it's slightly less than 2%. But anyway, it's not increasing. So the main purpose of this simplified example is to show that somehow the interest rate you see does not mean your actual power of purchasing goes up by the same rate. Okay, that's because we always have some kind of inflation. Okay, Of course, it is possible that deflation may also happen. That means the price of some goods may actually go down, right? So maybe right now, it costs $1 to buy a dozen of eggs. Maybe in 1 month, the price would be 90 cents, right? That's deflation, right? So it's not always inflation, but inflation it's likely the dominant case in our daily life, right? That's why we want to measure the inflation. That's why we have this CPI. It's the Consumer Price Index. Right? It's a basket of goods. In my example, there's only one goods, right? That's eggs. Well, in real life, we care a lot more than just the eggs, right? It could be a little bit. It will include many important consumption goods into consideration. So that is the purpose of this section, right? So mathematically, it's really, really trivial, right? So basically what we do is we will still have some notation. So we still use I to denote the unit period interest rate. This is actually effective interest rate, although here we call it the nominal interest rate. The name nominal is referred to or compared with the real interest rate. Real interest rate is the interest rate that removes the inflation part. So here, if this is the nominal interest rate and I set the real interest rate to be I, then I put a subscript, so put real to denote. Then what we have is 1 plus I equals 1 plus the real interest rate times 1 plus pi. So what is pi? Pi would be the inflation rate. Okay, so from this is rather trivial to derive the real interest rate from nominal interest rate, right? In most cases, we assume the inflation rate is positive. So you are dividing by a number that is bigger than 1. So in most of the time, if your inflation is greater than 0, your real interest rate should be less than or equal to the quoted interest rate. In my example, the quoted interest rate is 2%. The real interest rate will be smaller than that if there is inflation. Of course, if there's deflation, so the value of pi is negative, then of course you will actually enjoy much more if you put money in the saving account. That will give you a much bigger purchasing power. So that is the entire mathematics behind everything. It's really trivial, right? So for example, 5.5, they tell you the nominal interest rate is 8%, inflation is 2%, determine the real interest rate, while just the 1.08 divided by 1.02 minus 1. So you get about 5.88%, which is less than 8%, right? So the math from this section is rather simple, so I don't want to mention too much of it. Sometimes we may have the payments at different times. So and then you will do a little conversion to get it done. That's because, well, the payments are now at different times. So let's look at one such example 5.6. So let's do example 5.6. So here we have a bond pays 50 in 1 year, 1,050 in 2 years. So this is a standard coupon bond, right? So you can see 1,000 is the face value, 50 is the annual coupon. The real interest rate is 4%. Inflation is 2%. Determine the present value of the bond's cash flows. Well, in order to determine the present value, we basically want to know the the I, right? So the effective interest rate. So there is a little confusion of name because we used to call I the effective rate, right? But here we call it nominal. So the nominal interest rate here is not the same as the nominal interest rate we studied in chapter 4, right? That's the nominal interest rate per year convertible P times a year, right? So this is the P3 rate. Okay, the difference is quite obvious, right? So here we call it nominal. That's because it's paid more than once a year. Here we call the previously effective interest rate nominal interest rate. That's because we actually have the real interest rate as a comparison. Okay, from here we easily derive the I. Right, I would be 1 plus 4% times 1 plus 2% minus 1. So that is the nominal interest rate, or if we use our old term, it would be effective interest rate per year. It will be 6.08%. Once we know that, it's rather easy to find out the present value of this coupon bond, right? So it would be 50 divided by 1 plus I plus 1050 divided by 1 plus I squared, right? So this is the real. This is how we calculate the PV, okay? Which you will get the number to be this, okay? Sometimes we also want to know the textbook introduce an idea that would be the real cash flow. So this is the nominal cash flow. In order to get to the real cash flow, we will need to use the corresponding amount. For example, the first one is 50 divided by the inflation. So for instance, the real cash flow at time 1 would be this amount divided by 1 plus pi, so it's 1.02. Similarly, we can do the same thing for the second cash flow. The original amount is 1000, that's 1050 divided by 1 plus pi squared, okay? Once we take care of the inflation, then we can do the present value. So here we have two methods, right? So then we can do it using the real cash flow. So the real cash flow divided by the real interest rate plus the second real cash flow divided by 1 plus I real squared. Okay, you will get the same result. Right? The reason is trivial, right? Here's 50 divided by 1 plus I. We can write 1 plus I as 1 plus real times 1 plus pi. Of course, you can do the division first, right? And then divided by the increment or the accumulation factor under the real interest rate, right? So it's the same thing. So it depends. So it depends on how you want to solve this question. So this is enough. There's no need to go through the second one, although sometimes they may want you to understand that, understand the definition of real cash flow. So basically, that is the definition of real cash flow. Let me put it in a box, and then we can conclude this section. So real cash flow at time t would be the actual amount, whatever you will be received, divided by 1 plus pi to the t's. So pi is obviously the inflation rate. Okay, so that is the definition of real cash flows. I guess that's everything for this section. There is a slightly more complicated example, 5.7, but I believe you should be able to handle that.